So let me say it again. We need to correct this, and Thalia is not with us, so I'm gonna share the recording with Thalia. Probably start with Sean. Let's correct number 1 and 2. Yes. Did you find your answers? Did you find your answers? Yeah. Hello, Bijan. You're late for a reason? Not yet. Okay. Khalas, don't worry. If you send me an email, I'm gonna read it later. All right, Sean. So a coin is tossed vertically upwards. What happens to its velocity while it's in the air? What did you say? Okay, so as the coin moves up, I'm gonna say the velocity decreases until it reaches 0, right? It reaches 0. On the way down, the velocity increases, but in the negative direction. Because it's the way down. Easy. Part B, what do they want? Okay, which page? I will tell you in a moment. Sean, continue. Yeah, what is it equal to? The acceleration. Okay, the acceleration for free fall is always, yes, -9, yeah. Okay, so Zoya is asking which page. It's this page, Zoya. Wait a second, this page 99, okay? But you have a screenshot, that's why I did not write the page number. All right, the acceleration for free fall is always negative 9.81 meter per second to the -2, okay? -2, yes, that's it, all right? That's for acceleration, and never forget this. Okay, question done. Thank you so much. Hatem, can you do part C for me? Remember, this is something you already did. It should be on your notebook, so you just have to find it. Yes. Okay, because as you move up, gravity is against you, right? So you move up, you slow down, and you stop. Then you move back down. Okay? كل شيء أنت بتكبيه as you move up. By the way, I should remove my earphones because I want Thalia to listen to your questions as well. So I was saying that when you throw something up, it's gonna move up, but gravity is downward. That's why you slow down. Okay? Just imagine, Zoya, you throw something up and it will speed up to reach outer space. No, it's gonna slow down to stop at some point. Do you understand, Zoya?
Could you repeat?
Okay, so I'm saying when you throw something up, it's gonna move up, but gravity is downward. So that's why when gravity is against the motion, it's gonna slow down. Do you understand? Anyway, so if you don't get it, I'm gonna repeat it in each question, okay? Hatem, can you do part C, please? I mean number 2.
Yes.
Okay, what was the question?
A pebble is dropped down a well and hits the water 1.5 seconds later. Using the equations for motion with constant acceleration, determine the distance from the edge of the well to the water's surface.
Okay, so these are the equations I need. I'm gonna take them with me all the time. Let's see what given we have. When we say dropped, what is the initial speed?
0.
Yes, thank you. This is very smart. So V initial is 0. Is that free fall? when you drop something?
Yes.
So I'm gonna say acceleration is equal to negative 9.81 meter per second squared. So every time I have free fall, I have to use this. All right, what other given are we, do we have?
1.5 seconds.
What's this?
When it hits the ground.
That's the time, okay? So I'm gonna write time is equal to 1.5 seconds. And what is the question? So given question mark equation solve. What do they want?
So find the distance.
Okay, so they want x, I suppose. X is equal to question mark. Which equation do you want to pick? Any equation would work, and I'm talking about those equations.
It's delta x half acceleration.
Yeah, so I'm gonna say, by the way, you can write it as x is equal. All right, so I'm gonna say, what happened? 1 second. Okay, so x is equal to a half a t squared plus v initial t, and I'm gonna make sure this is squared, and I'm gonna use this again to plug in the values, right? Okay, so acceleration, do you have a calculator on you? Yeah?
Yes.
Okay, please do the calculation for me. The answer is
11.03.
11.03. Significant figures now. I have two significant figures. I should round this to two significant figures. Do you know how to round this to two significant figures?
So 11
11. And the unit for x is?
meters.
Thank you so much, Hatem. All right, I need Samir to do number 3. And I would want to insert a text box here to write the solution for number 3. Okay. Yes, Samir.
Alright, the ball is thrown vertically upward. What are its velocity and acceleration when it reaches its maximum altitude? What is its acceleration just before it hits the ground?
Okay, so they want to know what happens at maximum altitude. Can you tell me? Okay, so at maximum altitude, or in other words, at the top, right? At the top, what happens? What happens to V? And what happens to A?
It reaches 0?
Yeah, so V is 0 at the top. And what about A?
Also 0?
No, A is negative 9.81 meter per second squared always. Okay, what's weird is that I've been saying acceleration is negative 9.81 meter per second squared always, and I've been saying that for a week. Look, everyone is doing it wrong. Like Sean did a mistake, and now you, Samir. Acceleration never changes, it's gravity. When you are at the top of the motion, Earth is not gonna disappear, gravity is not gonna disappear, okay? I know it's a common misconception and it's a common mistake, so I'm gonna repeat it for it to become your nightmare. Like it will become your shadow. What is its acceleration just before it hits the ground? Just before it hits the ground, what is the acceleration? I want you to guess. شرفك قد ايه acceleration once just before it hits the ground. يعني it goes up then down. As it's going down, it's gonna speed up. Just before hitting the ground, what's the acceleration?
Is it 9.81?
Say it again.
Is it 9.81?
Yes, you see this always, it means it's not gonna change ever, no matter what happens. So acceleration is negative 9.81 meter per second squared, no matter what. Okay, no matter what. Yes.
Why is it always negative 9.81?
Yeah, because it represents gravity, and gravity is not gonna change whatever you do. If you speed up, if you slow down, if you're happy, if you're sad, if you're dead, if you're sleeping, if you're somebody pushed you, if you are at
where is gravity used in our lives or our daily lives?
Gravity will affect your motion. So let's say, and that's my phone, I drop my phone, it's gonna fall down, it's gonna break, I need to buy a new phone. It's gonna affect my life, no?
Is it playing a ball or playing a balloon requires a gravity?
Of course, if there's no gravity, the ball is gonna fly to the outer space. It's not gonna fall down to the ground, right? Of course, gravity will affect any motion. All right, so I'm moving this a bit. I think I'm gonna talk to Matthias. You're too many, and I want everybody to have a turn. So if I ever miss someone, please don't be sad. Okay. Yes, Matthias. Number 4.
Two children are bouncing small rubber balls. One child simply drops the ball. At the same time, the second child throws the ball downwards so that it has an initial speed of 10 meters per second. What is the acceleration of each ball while in motion? Acceleration will be negative 9.81 meters per second squared.
Thank you
and the
so
velocity
much.
will be 0.
Nobody asked about velocity. They don't care. They're just tricking you.
Okay.
The acceleration is not gonna change ever, ever, ever. So yes, they just want you to see. They just want to see if you got the idea. Thank you, Matthias. Fedi, number 5.
Okay. The gymnast practices to. Wait, are we doing number 5?
Yeah, I'm sorry. Give me 1 second.
Okay.
I believe my file is too ugly. So let me move it a bit. I'm so sorry. I'm actually so sorry, but this is killing me. Yeah, who's jumping inside? Oh my God, is that my daughter having PE? This is so
I mean, I
crazy.
can't hear anything, so.
No, I can hear like the house is being destroyed. It's that bad. PE teachers.
Okay.
I'm sorry. I'm really, really sorry. I hate this.
No, it's okay.
Okay.
Well,
now we can do number 5. Yes.
Okay.
A gymnast.
A gymnast practices to dismounts from the high bar on the uneven parallel bars. What is a dismount?
I think she's gonna swing. So during one dismount, she swings up off the bar with an initial upward velocity. So I think she's gonna push herself up. And the second, she releases from the same height, but with an inch. So it's just free fall. But you have 2 types of free fall. And here, I'm gonna try this with you. Question number 5. Question 5. Let me try to draw a table because I'm gonna write case 1 and case 2. Okay, so it's gonna be case 1. Just a second. Okay, so case 1, what happens? And we have case 2. For case 1, it's free fall. So I'm gonna take A to be negative 9.81. Let me take it from here. I do not type it every time.
Oh, this is like the acceleration we have to memorize, basically, right?
Didn't you already?
More or less.
Okay, so we have the acceleration, which is the same in both cases. Now V initial, in the first case, what's her V initial? I can see it's positive. Positive because she pushes herself up 4.0 meters per second, right? In the second case, V initial is negative because she's pushing herself downward. How do you push yourself downward? You push on something to move downward. What is her acceleration in each case? We wrote it already.
Calculator. Okay.
Okay. How does the final velocity as the gymnast reaches the ground differ from the second final velocity? We cannot calculate final velocity because we don't know the height and we don't know anything, neither the time. But my question for you is, if you jump with an initial speed of +4 meter per second as your initial speed. Let me stress on meter per second. I don't want you to think this is a position, it's an actual speed. Or if I move down with -3, which one will give you greater speed?
Wouldn't be okay.
So this is ground.
I want to, for some reason, I want to. Wait, the general speed should be like the final speed. You mean like
they want to know
speed?
The final speed, which is just before you hit the ground in this position. In which case your speed is faster, it's higher.
Aren't they supposed to be the same in the free fall?
They're actually close. Let me give you a hint. Free fall is symmetrical. So if you start with +4, you're gonna do +4, +3, +2, +1, 0. So this is 0. Speed equals to 0. I'm sorry for the delay in the writing, it's from the recording. And then whenever you go down, it's gonna increase 1, 2, 3, and 4. So when you reach the same horizontal line, it's gonna be 4 again, but negative. So it's as if you just started from here with -4. Compared to this motion where you start from -3, which one is gonna hit the ground with a higher speed? Case 1 or case 2?
Wouldn't it be case 2?
But case 1, you start with -4. -4 means faster. Case 2 is -3.
I thought negative because -2.
So negative means downward. If you want, let's never use negative anymore. I'm gonna say downward. So you start +4 upward, you reach 4 downward, and this is 3 downward. Which one is gonna reach the floor faster?
The first case, basically.
Yeah. So let's try to explain it by saying the following. I need to write here. In the first case, gonna have a speed of -4.0 meter per second as she reaches her initial position while going down to, I don't want to say hit the floor because she's not gonna hit, she's gonna reach, while going down to reach the floor. Which means she is going to reach the floor faster as compared to the case where she starts off with -3 meter per second. Okay, so going to. The first case, the girl is going to have a speed of -4 as she reaches her initial position while going down to the reaching floor. Anyway, the best way is also to calculate. How do you find V final? If you look here, V final is V initial plus AT. A is the same. T, we know nothing about it. V initial is greater. So definitely, we cannot really tell actually. We cannot really tell. Because as you move up, then down, or down directly, it's gonna be different timing. This one is gonna take more time. So we cannot use the equation to explain. We can simply use common sense, okay? Let me move this to the side. Yeah, that's better, like this.
Okay.
Yeah. Okay. I'm gonna wait a moment. Ya Allah, I'm sorry, but this is like really bothering me. Okay. That was number 5. What does it say? It says we did a lot of free fall. So we should be ready for a quiz about free fall. I'm joking, but the test will, do you think the test will include free fall? I think it should include, let me check. Because I don't want to give you
A little
another.
bit, please.
It says test 2, all of chapter 2. What's in chapter 2, ya Jessie? في 2.4? La. Okay, so free fall is included in the test, and it makes sense. Because look at it, we're done with the practices, and we're done with this. Now we have the red section. So by tomorrow, we will be done. And we can start chapter 3. I'm so happy. All right, now we have 2 choices. I can give you some conceptual, or probably give you something to try on your own in the remaining 10 minutes. And I'm gonna do that because I didn't have the chance to talk to everyone. Okay, so probably give you some work, otherwise physics is gonna be boring. So I want you to finish that before the end of the time. But this is classwork, which means I can help you with it. Do you think you can do it? And by 11 o'clock, you submit whatever you have. You get full grade even if it's not complete. Hatem, can you do that? Dijon, can you do that? But it's very important to submit something at 11 o'clock. Very important. Let me fix it so you can take a screenshot. This. Please take a screenshot. This is what you are required to do. Also, I'm gonna take those with me so you can have a copy next to you. This. So you can use it. Okay, another screenshot if you want. I'm gonna stop recording. Thalia, if you, no, probably I'm gonna send her a text. She's gonna do that after she comes back.